Welcome to this series of videos, and this is called Vacuum Tube TV for the explained for the radio DOI restorer. And this is intended for the folks that repair and restore old radios, and this will be a quick and easy to follow guide so that you guys can start working on vintage televisions. And we will be splitting this into 4 videos. This is the first one, where we will be giving an introduction to TVs. We will be talking about the different services that need to happen for a TV to work, and we will be talking a little bit about TV terminology. On the second video, we will learn how to identify different circuits on a TV and on the schematic. That will give you a very valuable tool. You will learn how to isolate a fault to a determined circuit and troubleshoot it very easily. On the third video, we will be talking about the first power up on your repaired TV, looking for a raster, looking for snow. We will be talking about common faults and linking them to their associated circuits. That way, when you have a determined fault condition, you won't need to look at the whole circuit of the TV, because that's very big and complicated circuit. You will be able to break it down into very small sections and isolate the fault to a determined section. So even if you're not the best troubleshooter, you will be able to know that the fault lies on this part of the circuit, and on the worst case scenario you can shotgun that part with parts and you'll probably get the TV to work. On the last part, we will be talking about applying signal to a vintage TV. How do we get picture into a 1950s or 1960s television? Restoration advice and approach, and safety. Don't be afraid to work around a vintage TV. You will not get killed. You will not get glass on your eyes. Lots of stuff are dangerous. You will not get cancer from radiation or whatever. Some stuff on a TV are dangerous, others are not. Some stuff is real, other stuff is just urban myths. I will explain to you the origin of those myths. I will explain what's really dangerous and what is not. And for the dangerous stuff, I'll be teaching you techniques to stay a little bit safer, so that you can work inside one of those without having any fear and with confidence. So first thing we're going to talk is why would somebody want to restore an old TV? I mean, they're black and white, they have a crappy picture, they are very big and cumbersome, nobody likes them, nobody wants them. Well, not true. If you buy, or if you cater for the small sets, like 17-inch or smaller, a 17-inch old TV is as big as a big German radio. So if you like big German radios and you have room for them, you also have room for a 17-inch TV or a 14-inch TV, or even those little portables. I mean, two portables are very hard to find, but most likely the smaller size you are going to find fully vacuum tube operated is 17-inch, but it's a very small set, so it's easy to have room for a bunch of them. And the TV is also always a nice conversation piece. If you have a 1950s TV fully working on your living room, it's as good or even better as having a tube radio. People will ask about it. On Christmas or on parties, you can put a vintage movie playing, or something related to your family, old tapes and whatnot. And if it works right, if it's working sort of properly, you will have a beautiful picture, a crisp picture. You might remember old TVs from your childhood as having lots of snow and you need to constantly adjust the antenna, and the picture was always crappy and there was buzzing in the sound and etc. But nowadays there is no over-the-air signals. For us to apply a signal to a TV, we will use a device called a modulator, and if the TV is working right, you will have a perfect, beautiful picture, and it will be worth it. Alright, so different services that are present inside of a black and white vacuum tube television and that are needed for it to operate. First thing we have is the antenna input, where you connect an antenna obviously, but now we will connect a modulator. After the antenna, you have your antenna terminals on the back, and there will be wires connecting to a device called the tuner. Inside of the tuner you have Inside of the tuner you will have two tubes, an RF amp and a mixer oscillator, which is basically the same that you will find inside of the front end of a radio. After the tuner you have your video IF. It's usually 3 stages, but can be less or more depending on the TV set you are working on. It's a pretty basic circuit, almost like the IF section of a radio. And then you have your video detector. It can be a solid state diode or a diode from a vacuum tube. Right here or right here, depending on the set, you have a tap where you have your audio section, which is also pretty standard. You have your audio IF, which is like the video IF but for the audio. It's usually 2 stages. After that you have your audio detector, much the same as the video detector. After the detector you have your preamp and your amp and the speaker. Okay, this is all pretty standard and not very troublesome. After this is where the magic happens. So after the detector you have your video amp, which is much the same as an audio amp tube. Amplifies the video signal and sends it to the CRT. Either tapped right here or tapped right here, there's the sync. In order to explain to you why we need the sync and how it works, we need to talk about how a CRT operates. So this is a CRT, and it's basically a large vacuum tube with a phosphor coating on the front. We have a cathode, a grid, and an anode. Again, I'm simplifying here. On the anode, which is that suction cup thing that you see connected to the tube, you'll find 15 to 18 kilovolts on a black and white TV. Don't be scared by this, it's not lethal, and I will explain that on the last video. But don't go poke around in there until you see that video and hear the advice. Okay, anode, cathode, grid. Typically the video signal is injected here in the cathode and it emits an electron beam to the center of the screen, which produces a dot. On the sides, on all 4 sides, we have what's called the deflection unit, deflection coils, or the yoke, which is this thing right here that contains 4 coils. 1, 2, 3, 4. 4 coils. Those coils deflect the electron beam horizontally and vertically and make it sweep the entire screen in order to produce a picture. Oh, and here on the grid you typically find a potentiometer, some sort of voltage dividing potentiometer. connected between B plus and ground in a certain manner, in a way that it varies the voltage applied here in order to bias the tube harder or softer, making it brighter or dimmer. And that is the brightness control. Alright, back to the sweep. Horizontal sweep works at 15 kHz and vertical sweep works at 50 Hz. So oversimplifying this, the electron beam basically does this. Until it fills the entire screen and gets back on the top. This is oversimplifying. So let's imagine that the vertical sweep fails. If the vertical sweep fails, you will see a straight line across the center of the screen. If the horizontal sweep would fail, you would see a vertical line across the screen. This usually doesn't happen because when the horizontal sweep fails, the high voltage to the anode of the tube also fails and you will not see anything on the screen. But if you did, this is what you would see. If you turn on a TV and you see one of these lines, turn the brightness down immediately, because if the line is too bright, it will get burned permanently on the phosphor of the screen. Alright, so back to this sheet of paper. As the electron beam is getting deflected vertically and horizontally, etc., the video signal is coming in. So how does the deflection sync with the video? That's a good question, because when the beam is right here, the TV doesn't know the precise location of the beam. There's no X or Y coordinates like we are used to work with today. So how does it work? Together with the video signal there are sync pulses, and those sync pulses are used to trip the oscillators that run the deflection coils, the horizontal oscillator and the vertical oscillator, and so they are in sync. They being in sync, the video information is transmitted in a way that it's perfectly synced with the deflection. I hope this makes sense. So that's the role of the sync separator. The sync separator is usually a tube or a set of tubes in a circuit, and it grabs the complete video signal plus the sync pulses, and it extracts the sync pulses from the video signal. Then it uses those sync pulses to trip the oscillators to make them run at the exact frequency that the video signal contains. Okay, so at the same time that the video amp is injecting the video signal onto the cathode of the CRT, the sync separator is separating the sync information, sending it to the vertical and horizontal oscillators, making them run at the precise frequency, and they are running the deflection coils that deflect the beam. All of this is happening simultaneously. If there is no video signal, there is no video information at all, what you will see is a blank raster. The screen will be completely illuminated, but there will be nothing on the screen. But yet, the vertical and horizontal circuits will still be operating at their frequencies, 15 kHz, 50 Hz. Actually, this is not entirely true, but we are oversimplifying. So they will be kind of free rolling, idling at this frequency, but once you inject the signal, the sync kicks in and makes them trip at the desired precise frequency. When you lose vertical sync, you will see the picture rolling up and down. If the sync is weak, or if the vertical cannot lock to the sync pulses, you will see the image rolling vertically, either up or down. It can be slow or fast, depending. We will talk more about that fault on I think it's video number 3 or number 2, I don't remember. If you lose horizontal sync, it depends. you can either see the image split into balls like this, or it can be split into diagonal lines like this. You know that there is a picture on the screen, but you cannot see what it is. So when you have this fault picture completely mangled, first you need to make sure that the horizontal is running at the correct frequency, and then you adjust the vertical. It's completely pointless to adjust the vertical, because if you cannot see the picture, you cannot see it rolling, you cannot adjust it. So adjust first the horizontal, then the vertical. This will be talked about in more detail later, just to let you know what it is. Alright, so we've covered pretty much everything that is inside of a TV, with the exception of the most failure prone part, which is the EHT supply, or high voltage. And the high voltage is contained in the horizontal section. We have our horizontal oscillator, like we described before. From the horizontal oscillator we go to the horizontal output tube, and this amplifies the oscillator pulses, and it works at about 15 kilohertz, and those pulses drive something that is called the flyback. The flyback is a transformer, which is sort of a switch mode power supply, old school switch mode power supply. So this tube drives this transformer, then goes to the high voltage rectifier, and we have here about 15 to 18 kilovolts, very low current. And this also drives the deflection coils. The high voltage accelerates the electron beam, make it hit the phosphor very hard. So if the high voltage is low, you will see a dim picture. Measuring this voltage is not very practical, but there is a method that you can use to kind of estimate it, and I'll talk about that later. So that's it for now. On the next video we'll be talking about identifying circuits on a TV. I will try to show you different chassis of TVs and how to look at them and identify the different circuits inside them just by looking at them. And we will also learn how to identify those same circuits on a schematic, on an actual service manual of a TV. So, learning how to isolate faults and learning how to identify the circuits inside of a TV is your most valuable tool for troubleshooting. Let's imagine that you have a TV which displays a horizontal line on the screen and nothing else. You will learn how to identify that, and you will learn that it's a fault on the vertical circuit. The vertical circuit is a not very complex circuit. It's usually very compact. It has maybe two tubes, a transformer, a bunch of capacitors, resistors and potentiometers. So if you isolate that on the schematic and you isolate that on the chassis, it's not that hard to test components until you find the faulty one. Sometimes looking at the complete schematic or looking at a complete chassis may look scary, it may look very complex, but if you learn how to break it down like this, it's actually very easy to troubleshoot. So, I know that this video is not the most professional video you have ever seen on YouTube. This is not profit oriented, I just want to share my knowledge. So if you like the content, if you want to see the rest of the videos, consider subscribing and sharing this with your radio fellows or with your friends that like radios, and maybe they will get interested in vintage TVs also.